For question number 7, the answer is 2.00. That is, the value of tau is 2.00 second. And to show the steps of solution, let us recall that one vector A, that is equal to A into I cap, and the other vector B, that was given as A cos omega t into I cap plus A sin omega t into j cap. So in step number 1, we shall find the vector sum and difference. The sum A plus B, when you find out, you simply add up the coefficients of I, then coefficients of j, and so on. Therefore, A plus B is coming out to be A into 1 plus cos omega t inside brackets into I cap plus A sin omega t into j cap. Similarly, the vector difference A minus B, you subtract the coefficients of I and then j and so on. So this A minus this is coming out to be A into, inside brackets, 1 minus cos omega t into I cap minus A sin omega t into j cap. That is writing the vector sum and difference in terms of I and j. So step number 2, finding their magnitudes. So recall that a vector r is equal to xi plus yj. Its magnitude is square root of x square plus y square. So in this case, we can write down the magnitude of A plus B vector, that is equal to under square root a square into 1 plus cos omega t whole square plus a square into sine square omega t. In the next step, you can expand it, taking a square as common. We have inside brackets 1 plus twice cos omega t plus cos square omega t plus sine square omega t. In the next step, well, note that we start from here, that is a square, and then inside the brackets it's 1 plus 2 cos omega t, but then cos square omega t plus sine square omega t is 1. This is coming out to be 2 plus 2 cos omega t in brackets. I take these 2 outside, that is square root of 2 a square into inside brackets 1 plus cos omega t. Recall the formula for submultiple angle now, and 1 plus cos omega t is 2 cos square omega t by 2. So you could write this as twice a square into 2 cos square and the submultiple angle omega t by 2. And then square rooting, you can report it to be plus minus twice a cos of the angle omega t by 2. That is the magnitude of the vector sum A plus B. Similarly, let's find out the magnitude of A minus B vector. Let me call this last result as equation number 1 for future reference. And to find out modulus value of A minus B, I shall copy a few lines and make rectifications on them. Just see it, it will be easier for me in writing. So we shall now find out the magnitude of a minus b vector, and that is, as you can see from here, square root of a square into, this now becomes 1 minus cos omega t whole square. Whether it's plus or minus, no difference, is plus a square into sine square omega t. So in the next step, a square into, inside brackets, this becomes 1 minus 2 cos omega t, then plus cos square omega t plus sine square omega t. As before, you can show this is 2 minus 2 cos omega t inside brackets, therefore square root of 2a square into 1 minus cos omega t. Another formula for submultiple angle, 1 minus cos omega t is twice sine square omega t by 2. So eventually you are showing here is coming out to be square root of 2a square into 2 sine square omega t by 2, and then square rooting. You are getting it to be plus minus 2a, and then this is sine omega t by 2. Let me call it equation number 2, right? Once we get these two results, 1 and 2, in step number 3, let us recall the condition given by them, and that is modulus value of a plus b is square root of 3 times modulus value of a minus b. And this means, well, this is here plus minus twice a cos of omega t by 2 is equal to here, this from here, so it's coming out to be plus minus root 3 to twice a sine of omega t by 2. From both sides, this 2a cancelling out, and you can show from here that tan of omega t by 2, that is coming out to be plus minus 1 upon root 3, isn't it? The many possibilities, if you take plus here and plus here, or minus and minus here, that's giving you plus value. On the other hand, a plus here and a minus here, or a minus here and a plus here, giving me this minus value. So tan omega t by 2 is coming out to be plus minus 1 upon root 3. A little bit of trigonometry here. This is tan of plus minus pi by 6, isn't it? Tan pi by 6, tan 30 degree is 1 upon root 3, while tan of minus 30 degree is minus 1 upon root 3. Now recalling the general solution of trigonometric equations, you can write from here, just making one more column on the right hand side. This is giving you omega t by 2, that is equal to n pi plus minus pi by 6, that the value of n can be 0 or any positive or negative integer. Given that this omega is pi by 6 radian per second, you can write in the next step, that is omega is pi by 6 units, so pi by 6 into t by 2, that is equal to n pi plus minus pi by 6. From both sides, pi is cancelling out. You are having t is equal to 12n plus minus 2 in seconds. Looking for the smallest value of t, realistic value of t, you put n is equal to 0. You get t is equal to 2 seconds, and that is the smallest realistic value of t, and that is also the answer of the problem. So you conclude that the smallest possible value of t, that is tau, that is 2.00 second, and that is the correct answer.